over voltage protection of SCR. The thyristor or SCR are very sensitive to over voltage. When the voltage across the thyristor is increased beyond its safe limit, as a result, the false triggering of SCR, that means the SCR may turn on even when gate signal is 0. Second, reverse. Due to the reverse breakdown, it may permanently damage. Causes of over voltage. So there are two reasons to produce over voltage across the thyristor, internal and external. Let me see internal over voltage. Internal over voltage arises due to during the turn-off process of SCR. So after anode current reaches 0, then this anode current reverses due to the charge stored in the SCR. The reverse recovery current rises to peak and then suddenly reduces to 0. So the value of di by dt becomes very high. So due to the inductor connected in the SCR circuit, a high transient voltage L di by dt is produced. As this, the over voltage may be several times of breakdown voltage of the devices. Now above these reasons, above this internal over voltage reason, SCR may be damaged. Now let's see external over voltage. So there are two reasons to produce or develop external over voltage across the SCR. First, lightning stroke, switching of transformer, switching of load. First, lightning strokes. Now when the thyristor systems supplied by the overhead transmission line, a higher voltage produced due to the lightning stroke on the overhead lines. Now these lightning strokes are attenuated by lightning arrestor and transformer in the circuit, but the value of external voltage may be greater than safer value. The magnitude of this external over voltage decreases with increase in transient time. Second, switching of transformer. There is a possibility to produce over voltage when transformer supply to the thyristors. When primary winding of transformer is connected to the load or disconnected to the load, high transient voltage induced in the secondary winding of the transformer. Now this voltage is given to the SCR, so it may be damaged. Third, switching load. So if the switches are provided on the DC side, when it is suddenly operated, it produces arc voltage. Now this arc voltage gives rises to the over voltage across the SCR. Now if the SCR circuit is connected to the highly inductive load and a sudden interruption in this load which produces higher voltage across the SCR. Different methods of over voltage protection for the SCR. In order to keep minimum protective component, thyristors are chosen with their peak voltage rating of 2.5 to 3 times their normal working voltage of the circuits. So there are two methods are used for the over voltage protection. First, Snubber circuit. Second, non-linear surge suppression. So already I told you, Snubber circuit, it is a series combination of capacitor CS and resistance RS. Now this series combination is connected in parallel with the thyristor, which is required to be protected. Second, due to the on-off of primary winding of the transformer, a transient voltage induced in the secondary winding. Now to separate this transient voltage induced in the secondary winding, Snubber circuit is connected in parallel with the secondary winding. So it provides protection against the over voltage. Second, non-linear surge suppressor. So non-linear surge suppressor is a non-linear devices which are connected in parallel with the thyristor or SCR. It offers very high resistance at normal voltage. Hence, a very low amount of current passing through it at normal condition. But it offers very low resistance at high transient voltage. So it acts as a short circuit. So the majority current is passing through these non-linear devices. So now due to this, high voltage drop occurs in the source and impedance of the line. So there are three devices are used in the non-linear surge suppressor protection. So first, varistor. So varistor is a two-terminal semiconducting devices. Varistor is a variable resistor whose resistance depends on the applied voltage. The word varistor is formed by combining the variable and resistance, and it is also called as a VDR, voltage dependent resistance. That means the value of resistance depends on the voltage. So varistors are made of thyroid or matrocell material, but power losses occurs in healthy condition, so its use is limited. So nowadays metal oxide varistor are used for the protection. As shown in figure, the two metallic electrodes or two metallic plates are separated by the grain of zinc oxide, which is bound with another oxide. Now, its boundary characteristics is similar to the characteristics of PN junction diode, and the device characteristics of this various varistor is similar to the characteristics of avalanche diode. Now this varistor is available in a range of 6 volt to 2800 volt. Second, selenium surge suppressor. The selenium metal rectifier is used for the rectification in the past, but nowadays it is not used for rectification, but it is used as a surge suppressor. Forward breakdown voltage of metal to selenium junction is low, but high reverse breakdown voltage. Now, as shown in these characteristics, before the operating point P, very small amount of current passing through it. When the transient voltage appear and cross this point P, a very high amount of current passing through it. Now there are two types of surge suppression. First is polarized type and second is non-polarized type. In polarized types, all the plates are kept in only one direction. So the overvoltage protection provides in only one direction. For this reason, it is used in DC circuit only. In non-polarized type surge suppressor, the plates are kept in both directions. So the overvoltage protections is provide overvoltage protection in both directions. So for that, this non-polarized type suppressor is used for AC circuit. Now, third, avalanche diode. Avalanche diode, it is also a semiconducting device. Avalanche diode flow currents in both forward and reverse direction. But this avalanche diode is specially designed to operate only in reverse condition. So now when the reverse voltage appear across this device, very high amount of current passing through it. So the point at which the current will flow in reverse direction is called breakdown voltage.